In this question number 5, we have atoms and ions, and we are talking about 3 subatomic particles, protons, electrons, and neutrons. And if we have this number on top, that is called the mass number. That is also known as the nucleon number. It's to do with the number of protons plus the number of neutrons, protons and neutrons in the nucleus of an atom. So carbon has 6 protons. That is the proton or the atomic number. So what we have there will be 6 protons. We have a 2 minus charge there. So that's because we have gained 2 electrons. There's 8 electrons. We have 14 minus 6, which is 8 neutrons there for this isotope of carbon 14 there. In terms of this next part of the questions, I don't think you need to relate, you need to learn about them. They are from the old syllabus prior to 2016. This was the group 14 chemistry that they would have learned previously. But the CCl4 is basically inert to hydrolysis as the CCl bond is the longest out of the 3. It's the shortest out of the 3 actually, because of the small size of carbon. So if it is the shortest, something is definitely wrong with this thing here today. It's the shortest bond out of CCl versus GeCl versus the SnCl. And therefore it is the strongest bond, and therefore not easily hydrolyzed, not easily broken or hydrolyzed. Okay, but as for the rest of it, I don't think we need to talk too much about that. That was basically the reason for the reactivity. This is in the AS bonding 2022 syllabus, where they will expect you to relate bond energy, covalent bond strength with bond length. This is to do with the size of your atom, and then you can relate to reactivity. If you need to break the bond, are you breaking a stronger bond or are you breaking a weaker bond? All right. As for this chemistry, this is actually quite a useful A2 electrochemistry question. So what you need to do is, we need to know that Cl2 is an oxidizing agent. So that's straight from your AS chemistry of halogens. So when that is true, if we look at the E0 value from the data booklet, so what does the Cl2 give me? Cl2 plus 2 electrons, that one is plus 1.36 volt. Should probably write better then, plus 1.36 volt. And then you are trying to use this as an oxidizing agent, so you're oxidizing the Sn2 plus to Sn4 plus. So we're looking at the Sn4 plus on the left hand side, because everything in the data booklet, the E0 value shows you reduction potential. So we have E0. Okay, I gotta fix this thing now. Okay, E0, Sn4 plus and Sn2 plus, and that give me plus 0.15 volt, whereas the E0 Pb4 plus and Pb2 plus, that give me plus 1.69 volt. So we are saying that there is a reaction between Sn2 plus and Cl2. So if we have a reaction between Sn2 plus and Cl2, what we're gonna get will be the Cl minus and the Sn4 plus. So Sn4 plus there, so 2 Cl minus, that will lose 2 electrons, and this will lose 2 electrons, and this will gain the 2 electrons. So this is the balance equation, and what you have there is your E cell, which is your E red minus your E ox. And if that is true, the Cl2 goes to Cl minus. This is going to be your E red, and this is going to be your E ox. So you can see that something which is more positive minus something which is less positive, you're going to get something positive. 1.36 minus 0.15. Your calculator show you 1.21, but you need to know electrochemistry must have sign, must have value, and must have unit. And you can relate this to the new syllabus. The new syllabus say delta G equal to minus NF E cell. And if the E cell is greater than 0, so the delta G is going to be lesser than 0. So what we can say is spontaneous. and also feasible reactions related to delta G there. But an aqueous solution of PbCl2 does not react. So now we are onto the negative bit now. So if we react, if Cl2 oxidizes Pb2 plus to Pb4 plus, we need to show the E cell is going to be the E red, which is the Cl2 acting as oxidizing agent, so they will undergo reduction. So the E red is plus 1.36 from the chlorine, and then that is minus plus 1.69. As you could see, something smaller minus something bigger, that is going to be negative, and your calculator will show you something negative. So your delta G there, which is minus NF E cell. So N is the number of electron transfer, which is 2 electrons. F is a positive Faraday constant. Minus and the minus will give you positive. So delta G will be greater than 0. This is not feasible, not spontaneous. Answer the first bit, answer the second bit, write an equation for this reaction, which we already did, and that's the end of that 3 marks. Kind of a good electrochemistry question, although it's more related to all the syllabus on the group 14 chemistry there. Now this next bit of the question is definitely just electrochemistry, so this will be relevant to the current syllabus as well. What is the relationship? You just need to state it. So this is F equal to the Avogadro constant multiplied by the electronic charge, which is the charge for 1 electron. Faraday constant has a unit of 96,500 is the value. The unit is coulomb per mole. This is the charge. Is the charge for 1 mole of electrons. It's a charge for 1 mole of electrons. If you have the charge for 1 electrons, you multiply by 1 mole of electron, you're going to get the charge for 1 mole of electron. That's basically what it means there. Now when you pass a current of 1.2 ampere and you pass it over 30 minutes into dilute sulfuric acid, we are going to do an electrolysis of dilute sulfuric acid straight from your O level or IGCSE level chemistry. You have the sulfuric acid, which give you H plus, SO4 2 minus, H plus and OH minus. So the H plus is just going to, dissociate one of them. And when I say dissociate, what I mean is discharge. Discharge at the cathode, that's the right word. Between the hydroxide and the sulfate is the hydroxide that's going to get discharged. So the H plus the 2 electrons that will go to the H2. This will happen at the cathode. Reduction happen at cathode for your electrolysis. As for your OH minus, the OH minus will become O2 and H2O and electrons, and you balance the equation with 4 OH minus and 2 H2O and 4 electrons there. So that is your oxidation at the anode there. Oxidation at the anode because reduction happened at the cathode. Overall, what you're gonna get is you're gonna get the H2O getting electrolyzed, the H2O getting electrolyzed to give you hydrogen at the cathode and oxygen at the anode there. And you're going to have H2SO4 remaining, and in fact they're going to become more and more concentrated as these electrolysis continue there. So what do we get? Blah blah blah. This is the reaction that happens at the anode because this is oxidation. So this is an alternative equation which you can write. It's pretty much the same thing as that. It's just the water dissociating in solution to give you the O2 and the water there. And the OH minus come from the water. So essentially you're still losing electrons there, and you will still get the completely balanced equations even if you write these, or these will be pretty much the same there. But what do they want here? They want you to calculate a value for Avogadro constant. They're trying to guide you. There are 5 things to be calculated there, and there are 4 marks to run up these 15 marks questions. So let's try to do them one by one. First of all, calculate the number of mole of oxygen produced. So let me just number these stuff that they want us to calculate. So number 1, the number of moles of oxygen produced. Oxygen is a gas, and I get 130 cm cube there. So this is the gas volume, and this has to be divided by 24,000. Oh, this is frustrating. Something is definitely wrong with this thing here. So 130 divided by 24,000, and this is cm cube, and this is cm cube per mole. We know that in the periodic table at the bottom, it's given as 24.0 dn cube per mole. Here's 24,000 cm cube per mole because it's in cm cube there. So we want to calculate, so we want to give a value. So, you know, calculate and put it into a calculator. 130 divided by 24,000. I get 5.417 times 10 to the minus 3 mole. I don't want to run up too early, so I just leave it as 4 significant figure for the time being. That should be enough. Now, what is the number of mole of electrons? Well, from the equation, 4 mole of electrons react with, well, is produced along with 1 mole of oxygen. So I will relate the mole of electrons to the oxygen. 4 mole of electrons, 4 mole of electrons is to 1 mole of oxygen, is to 1 mole of oxygen. So what is my actual mole of electrons is to the 5.17 times 10 to the minus 3 mole of the oxygen. So students who are used to my channel, you know that this is the usual method I like to use when I talk about, this is really frustrating actually, when I talk about my mole ratio. So actual number of mole of electrons is going to be 4 times that answer from the previous bit. 5.417, 5.41, I can't even press my calculator correctly, times 10 to the minus 3 times 4, so this one will give you 0.021668 mole, 21668 mole, okay, never mind. So now I need to find the number of coulomb pass. This depends on the question. So you pass 1.2 amperes over 30 minutes, so we know Q equal to IT, I there, and then the T is to be in seconds, so it's 1.2 times 30 times 60. So Q is equal to IT. That was 1.2 amperes, and multiplied by 30 minutes, converted into 60 seconds. Well, converted into seconds by multiplying by 60. So 1.2 times 30 times 60, I get 2160 coulomb. So this much mole of electrons is for 2160 coulomb altogether. What's the next thing that they want? The number of electrons pass. The number of electron pass. If you look at the data booklet, of course, you'll be given this data in the question for the new syllabus, obviously. So we know that this charge, 2160 coulomb, is for 0.021668 mole of electrons. What are we trying to find actually? We want to find the number of electrons, that are passed. We know that the charge of one electron stated in the data booklet will be 1.60 times 10 to the minus 19 coulomb. So I guess if that is for that, we want to find the mole of electrons, right? We want to find the mole of electrons. So what do we want? We want the number of electrons passed. This is for one electron, and we have this much charge. This is for one electron. I think I've gotten this the other way around. So, you know, 2160. Nope, that doesn't make sense. 1.60 times 10 to the minus 19 coulomb is for one electron. So 2160 coulomb is for how many electrons? Yeah, that seems to be the right way around. For direct proportion. So you have greater number of charge, that means you must have greater number of electrons, like that. So 2160 divided by 1.6 times 10 to the minus 19, I get 1.35 times 10 to the 22 electrons. This is the number of electrons. Last but not least, what do I need to do? I need to get the number of electrons in 1 mole of electrons. So we know that this is the mole of electrons, and this is the number of electrons. So the relationship between Avogadro constant and this actual mole of electrons is going to be the charge for 1 mole of electrons. What am I doing actually? We want the number of electrons passed, so we did. We want the number of electrons in 1 mole of electrons. The number of electrons in 1 mole of electrons. So the number of electrons is equal to Avogadro's number multiplied by the mole of electrons. If we want the Avogadro's constant, now what do they want? They want the number of electrons passed. That one should be okay. The number of electrons passed. The number of electrons in 1 mole. The number of electrons in 1 mole is Avogadro constant. So that is the number of electrons divided by the mole of electrons. That is the number of electrons, which is 1.35 times 10 to the 22, divided by the number of mole of electron from the previous bit of the question earlier. And this should give you your Avogadro constant divided by that. And I get 6.23 times 10 to the 23, and this is a 3 significant figure. It is the number of electrons in 1 mole of electrons. Okay, so that's the end of that 4-mark question, and that concludes that 15 marks question overall.